Welcome to lesson 2.5 in geometry. Today we're going to learn about polygons. A polygon is a closed geometric figure in a plane in which line segments connect endpoint to endpoint, and each segment intersects exactly two others. A side of a polygon, each line segment of the polygon, and a vertex of a polygon is each endpoint where the sides of the polygon meet. So I'm going to sketch some polygon that has 7 sides. Oh, just use this. So here's one side, 2 sides, 3 sides, 4, 5, 6, and 7. Now this is made up of segments, and each point is the intersection of 2 segments. So if I want to draw an arrow to a side, this would be one side, and it says circle a vertex. There's 7 of them, but I'll just choose that. That's a vertex. Each point where these 2 segments meet will be a vertex. A convex polygon is a polygon in which no segment connecting 2 vertices is outside the polygon. An example of that would be something like this. That would be a convex polygon. A concave polygon is a polygon in which at least one segment connecting the 2 vertices is outside the polygon. So the previous one we did was a concave polygon. So this would be a concave polygon because I could draw a segment out here where there'd be a vertex inside these 2. So since it goes in like that, we call that a concave polygon. Now, if a polygon has 3 sides, we'll call it a triangle. 4, we'll call it a quadrilateral. 5 sides would be a pentagon. 6 would be a hexagon. 7 would be a heptagon. Even though sometimes with 7 you see the word septagon. That would work also. 8 is an octagon. 9 is a nonagon. 10 is a decagon. 11 is undecagon. And 12 is dodecagon. Now, if it's bigger than that, say it's 64, we'll just call it a 64gon. There are some names for some bigger ones, but we don't need to. Consecutive vertices are 2 vertices in a polygon connected by a side. So I'm going to sketch a polygon, or a pentagon here. A pentagon, we just learned, has 5 sides. So there's a 5-sided polygon. It's closed. So if it says circle 2 consecutive vertices, those are 2 vertices in a row. So here's a vertex. Here is another vertex. There's 2 in a row, so that would work. Any 2 in a row. I could have picked these 2, those 2, those 2, or those 2. Our next term is consecutive sides. This is 2 sides of a polygon that share a common vertex. So now I have to draw an octagon. Now octagons, I always think of stop signs. Because they're octagons. So there's an octagon right there. And I draw an arrow to 2 consecutive sides. Well, there's a side, and 2 consecutive sides would be 2 in a row, like those. Consecutive just means 2 in a row, or in a row, I should say. A baseball team could win 5 consecutive games, that's 5 games in a row. Consecutive angles, 2 angles of a polygon that share a common side. So I'm going to sketch a quadrilateral. Remember, quadrilateral is 4 sides. Have 2 consecutive angles. could be this angle and that angle, because there are two angles in a row. So consecutive just means in a row. Congruent polygons, two polygons are congruent polygons if and only if their corresponding angles are congruent and all their corresponding sides are congruent. So both those need to be true. So if I draw some two congruent triangles, I will draw one triangle down here, and just so I know for sure it's congruent, I'm going to copy it and paste it. I know on your paper you can't copy and paste, but do the best you can. So here, if we have triangle ABC and triangle DEF, if these triangles are congruent, we know this side is going to be congruent with this side. AC is going to be congruent with DF, and CB is going to be congruent with F. Also, we know angle C is going to be congruent with angle F. Angle A is going to be congruent with angle D. And angle E and angle B are going to be congruent. So those